All right. So yesterday we just covered some basics on probability, right? Um, Today we're gonna now see the application. Those things we discussed yesterday, like an event, the sample space, probability of an event, the complement of an event, the union, intersection, all those things are going to come into play today. And what I've done, I must say, I've actually taken questions from past papers, and these are grade 12 past papers. And that's why I've invited grade 12s that you'll be here, grade 10s you'll be here, grade 11s that you'll be here, because these concepts are all linked, all right? And when you're in grade 12, you may be tested on a grade 10 concept, you may be tested on a grade 11 concept. You cannot just forget things you have learned in lower grades, because mathematics by its nature is a cumulative subject. We build on previous concepts. All right, so I hope you still remember what we said about the union, which is basically combining, and the word or is common. The intersection, which is basically taking that which is common. So union, combine, intersection, common. We did Venn diagrams, and yesterday or last night, our Venn diagrams focused on the number of outcomes, if you remember that experiment of rolling a die. But there are Venn diagrams sometimes that are just based on probabilities, and we will look at those. I will explain how those work as well. Another important concept we looked into, in fact, someone asked a question on this, was the concept of mutually exclusive and mutually inclusive events, okay? We said two events are mutually exclusive if they do not have anything in common. In other words, the intersection is 0. And then obviously they will be inclusive if there's something in common and the intersection is non-zero. Excuse me. Then we talked about exhaustive events. For this one, we said if you can take the union of two events and you realize that combining the elements from both events, you get the entire sample space, then we say those events are exhaustive. On the other hand, we said when events are both mutually exclusive and exhaustive, then they are actually complementary. We closed it off by discussing independent events, and I'm going to remind you of that formula. We said for independent events, if I take the probability of A and B, I must get the same result as multiplying the individual probabilities. For complementary, remember, they must be both mutually exclusive and also exhaustive. So those are a few important things that we looked at yesterday. Right. Let us now look at our first example, again taken from one of the metric past papers. We are told here that two events, A and B, are shown on the Venn diagram. It is given that the probability of not A or B. So take note, this is what they have written. They are saying to you, and this is why notation is very important, and we talked about this yesterday. They are talking about the probability of not A or B. So you need to understand what this means. This means the probability of the complement, the complement of the union. Now remember, the union would refer to everything here that I'm shading. So this thing of not A or B simply refers to what is outside. Yes, this is grade 10. The current question is definitely at grade 10 level. So look at this. That is actually what we are being given. We are given not, that is the complement of A or B, meaning what is outside the union. So I need you to be alert to that. If you can be alert to that, then look at how easy this thing is now. Watch this. So I know that outside the union, I've got a 0.41. But what did we establish? We have established that if I actually add all the probabilities, that is, if I add the x, I add the 0.11, I add the 0.19, and finally this 0.41, I must actually get 1. That's what we have established. So for you to find the value of x, you have to remember that all probabilities in a Venn diagram must add to 1. If you cannot remember this, an alternative is the complementary rule. What does the complementary rule say? Remember, the complementary rule says, if I know the probability of an event is equal to something, then the probability of the complement of that event will be 1 minus the probability of the actual event. So why am I giving this? I am saying to you, you are given the probability of not A or B. So you must know that the probability of A or B will have to be a 1 minus the 0.41, which is the probability of not A or B. So there are actually 2 ways to solve this problem. One way is to do this, one way is to just add up everything and say it must be equal to 1. You can choose which one is easier for you, but I will do both in any case. So let us start with the first method. So of course, we're going to add up those that 0.11. I'm going to add the 0.19, and I'm going to add the 0.41. That gives me something like a 0.71, and I have to subtract that from 1, so it turns out that x is actually a 0.29. Now, if I used this formula here, I will gather that the probability of the union is actually 0.59. Now, what does that mean? It means if I add x and I add the 0.11 and the 0.19, I will actually get a 0.59, because that's what the probability of the union is. And I will leave it up to you now to check whether you will still get a 0.29 if you solved for x. Of course, you should. So just like that, we have found the value of x, but we are not done. We have to calculate the probability of A. Well, it is quite simple. The probability of A has to be everything in A. So basically, the probability of A in this instance will just be x, which is 0.29, plus the 0.11. Remember, the intersection in this case is part of that A. It's part of A. So this will be the result. We will have something like, I think, a 0.4. And just like that, you are done. Now, yesterday, we talked about shading, the importance of knowing how to shade Venn diagrams. And guess what? This next question here, matrics know very well when it is 11.1.2. Indeed, this is from a paper 1. It was question 11. So I want to remind you on the shading how you would actually shade this. So we want the probability of A or not B. So this means the union, right? So it is very important to consider the fact that in this instance, let's label, I'm going to just replicate this, but I want you to just note and be aware of what's going on. So watch. The probability of A in this case, right? A means I'm only going to color, remember? A means I'm only going to focus on what is in A. That's what it means. Now, I'm just going to draw a separate Venn diagram to show you what not B looks like. And I want to remind you of this. And I hope you get to also practice this yourself. So not B is something like this. Basically, whatever is outside B, right? So here is not B. So that's not B. Now, what does or mean? The word or means you have to combine the coloring. So bring these two colors together. That is what will give you A or not B. If we looked at and, if it was and, we will only take the common shading. I want to remind you of that. So in this case, if we're going to go for a situation where we combine the two colorings, I hope you will agree with me that we are talking about whatever is outside. So I'm going to color this one in the given diagram. We are talking about what is outside. I'm going to start with so I'm imitating the blue right now. But we must also color what? Whatever is in A, which means this portion. So to find the probability of A or not B then simply means I have to add up every number that is in the colored area, because those numbers are already probabilities. So we already know X is 0.29. We know the intersection is a 0.11. And finally, the 0.41. And just like that, you have the probability of A or not B. I promise you, whether you're in grade 10, 11, or 12, this is a question to expect. Right. Let's look at another one. Here, there's no Venn diagram given. All that you are given, you are told that probability of A is a 0.45, probability of B is a 0.25. Now, you are asked to determine the probability of A or B on this one condition. What is the condition? Well, the two events are mutually exclusive. And what does mutually exclusive mean? There is no intersection. So in other words, the probability of A and B is 0. You got to remember that. Okay? Pure maths, yes, this is essentially for pure maths, but I know maths lit guys also do probabilities, so it will be quite beneficial for you to also tune in. Whether you are maths or maths lit, this is a topic that is common to both subjects. All right. Now, yesterday I introduced to you what we call the fundamental formula for probability, and we said probability of A or B generally is probability of A plus probability of B minus the probability of A and B. That's what we said. So let's do our simple substitution since we know the probability of A and the probability of B. So this will be basically 0.45 plus 0.25 minus a 0. It doesn't really matter. You don't have to add that. And then everyone should see. If not, guys, please, you have calculators for a reason. So don't try and be a super. If you take time to add decimals, it's okay, we understand. Just use your calculator, be safe. You'd rather get this mark than lose it trying to shine up. But then that's the question, right? You're not really there to impress anyone. You are here to work for your marks. So add those up with your calculator if the need arises. Okay, so as you can see, this one was just an easy 2 marks, and this is an examiner who says, let me check, did this student really learn their probability in grade 10? And this is what they will present in cases like that. Like I said, this is actually from a metric paper. So trust me, matrix, you need to remember your probability knowledge as far as grade 10. Cool. Next up, we've got another one, And I want you to note again, we are given two events here. They are telling us A and B are two events in the sample space. And in this particular sample space, the probability of A or B is equal to 0.8. And the probability of B is 0.4. So what is happening here? You are not given anything relating to the intersection. But I want you to note the follow-up questions, or the questions that are linked to this statement. You have to calculate the probability of A if the events are mutually exclusive, and then you have to also calculate the probability of B if the two events are independent. Okay, so I want to show you, this is just a matter of playing with mathematics. If you enjoy algebra, solving, manipulating stuff, this will be easy waters for you. So let's start with the first one. If the events are mutually exclusive, remember what that means is that the joint probability, that is the probability of the intersection, is just 0. So this means probability of A and B is actually 0. So for 10.1.1, my formula would be as follows. Probability of A or B is equal to probability of A plus probability of B minus a 0, and I'm not even going to bother myself and put a 0 there. I know probability of A or B is 0.8. I am looking for probability of A, and I have been given probability of B, which is a 0.4. So surely, to get a 0.8 from a 0.4, you need to add another 0.4. So, or you can simply go 0.8 minus a 0.4. And you will all agree that in this situation, probability of A must indeed be 0.4. All right, guys, physics lessons do happen on Sundays. There is a WhatsApp group for that. Just try and follow our WhatsApp channel, and you will see that thing as well. You will see that physics group. There's a link in the channel there which allows you to join the physical science group. All right, cool. 10.1.2. Find the same probability of A if the events are independent. So yesterday, we established something, that when events are independent, let's write it down. When events are independent, then probability of A and B is actually equal to the probability of A times the probability of B. That's what we established. So I'm going to write down my fundamental law for probability. That law says probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Now, do I know what probability of A or B is? Yes, it's a 0.8. It has not changed. Do I know what probability of A is? No. Under this condition, we don't know if the two events are to be independent. We don't know. So you can't use the previous answer, right? So this is actually what you are looking for. So let's keep it like that. But we do know probability of B. We do know probability of B. Probability of B is actually a 0.4. Now, this is where this little formula, or knowing that little thing, will pay in. What are we going to do? Well, probability of A and B under independence is probability of A times probability of B. But we know what probability of B is, right? Probability of B is 0.4. So watch what I'm going to do here. I just want to complete the substitution. So then I get 0.4 times probability of A. Okay? That's after substituting. So this 0.4 here is for probability of B. I've just swapped them around. Remember, multiplication is commutative. In other words, the order of multiplication does not matter, because 2 times 3 will give you the same result as 3 times 2. That's what I've kind of done here. So I hope that didn't confuse you. So now it's time for like terms. When you have a linear equation with one unknown, what is our one unknown here? Our one unknown is probability of A. So whenever you've got a linear equation with one unknown, all you do is you bring like terms together and you have constants on one side, and that's it. So what I will then do is I will have this, and I'm going to write this so that everyone sees it. So you know that little thing that we say, you move a number to the other side of the equation, it changes sign from positive to negative. You know that, right? So that's what I've done here. 0.8 minus 0.4 is equal to what? Watch what I have on the right-hand side. I have probability of A minus 0.4 times probability of A. Now, this can be a bit confusing or intimidating, especially when you're in grade 10. But I want you to just regard probability of A as X. So imagine you've got X minus 0.4X. Just imagine that. These are actually like terms. So you have 1x minus 0.4x. That should, I hope you agree, should give you a 0.6, because these are actually like terms. So this should be 0.6 times probability of A. And obviously 0.8 minus 0.4 is just a 0.4. Now we are solving for what? For probability of A. So again, I invite you to imagine having something like this. Having 0.4 is equal to 0.6x. How do you solve for x? Well, you have to undo the multiplication, so you divide by 0.6 both sides, right? So that you just left with x on the one side. So that's exactly what we're going to do here. We're going to take the 0.4 and we're going to divide it by the 0.6, okay? And it turns out that our probability of A under these circumstances will be 0.6 recurring. So you maybe want to say roughly 0.67. So that is the long and the short of it in this case, guys. It is very important. I hope you are seeing this and you are appreciating this. It is very crucial that you understand the implications of such simple words like events being independent, events being mutually exclusive. So how did we get 0.6? I said, so look at this one here. This is where we got 0.6. You have 1 minus 0.4. So you have PA, look at PA as x. So you have like 1x minus 0.4x, like terms. So you just do 1 minus 0.4. That's what gives you a 0.6. So I hope that helps you there, Kabele. Great. I've got really a lot of questions here. So let's move on. This is recorded, so you will get the recording as well. I will upload it right on this profile. Again, look at this. We are told here, let A and B be two events in the sample space. Suppose that probability of A is 0.4, probability of A or B is 0.7, and the probability of B is some number K or value K. Question 11.1. For what value of K are A and B mutually exclusive? Question 11.2. For what value of K are A and B independent? I hope you realize how this question is exactly this question here. The only thing that they have done or seem to have done to make our lives slightly easier is just to replace probability of B with the letter K. But rest assured, you actually gonna do the exact same thing as we did previously. And so I want you to take this one as a little homework for you to test your understanding of what we did here previously. And yes, thank you, Maditsepisho. I like how you have actually made it easy for the student there. You can just take out X as a common factor and you will get that. Lovely. Right. Another one, we've got events A and events B, and we are told that these are mutually exclusive. Furthermore, it is given that the probability of B is twice the probability of A, and probability of A or B is equal to 0.57. So again, very similar to what we've done, but then here, since there's some form of substitution, one probability is going to replace the other. Maybe I think I'll take you through this one also so that you get to see the algebra behind it all. So we know, again, using our fundamental rule, probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. But we already know that these two events are mutually exclusive. So what does that mean? It means the probability of A and B is 0. So we can just substitute as 0 there. The probability of A or B is given as 0.57. And the probability of A, we want to calculate the probability of B, right? So I want to try and make it simple so that you don't have fractions. So in the place of probability of B, guys, I'm going to use this fact. Watch. They said the probability of B is twice the probability of A. So I'm going to replace PB with 2P of A. Okay? And again, Kabele, guess what? We are back to that story of adding up and all that. So since you get the factorization, imagine this. I factor out the probability of A on the right-hand side, then I'm left with a 1 plus 2 in brackets. If I factor that out, and then I've got a 0.57. Okay? So guess what? I end up with a 3P of A is equal to 0.57. Your job is very simple now. It is to divide. Yes. Your job is now to divide the 0.57 by 3 because we are solving for P of A. So we get 0.19 is equal to P of A. But have we answered the question? Not quite. Your question actually requires you to calculate the probability of B. So please beware. Now, to calculate the probability of B, we will then say probability of B is twice probability of A, so it must be twice the 0.19. And I'll leave it up to you to note that will become a 0.38. Okay. Very nice and easy. That's the beauty of knowing the language that is being used in mathematics. And I promise you, I mean, it's not that you don't know this. You do know this. You do know this. But what makes it difficult in the test exams is not understanding the words and all that. So, Unati, remember, we factor out PA. Yes, Tine, I think, is trying to answer you there. So that's perfect. Cool. Let's continue. Let's continue and do this and see how it is now if they ask us to draw a Venn diagram. I selected this one because we want to see now what do you do in a case where you have to set up a Venn diagram. Let's read. Okay, and I always emphasize this, that I know you are pressed for time in the exam, but don't rush to answer a question having not read the context in which the question was asked. So always try and read and understand the conditions surrounding that particular question, so that when you answer within context. Sometimes you find that, yeah, there's nothing wrong with the method that you used and all that, but the problem is whatever method you have used does not actually answer the question. It's completely not even unrelated to the question. So please make it a habit to always read. If you read for the first time and you don't quite get what's happening, try it for another second run, read and maybe read slower also, so that you kind of get into the context of the question. All right. This one here starts off by saying the probability that event A will occur is 0.5. This is not different from saying P of A is 0.5, which is a half. The probability that event B will occur is 0.6. And the probability that neither of these events will occur is 0.1. And this is where the big question comes. What actually are you given here? I hope you take note that this refers to the complement of the union. Now, calculate the probability that both events A and B will occur. Now, I know some students would quickly want to rush to a complete event diagram, and then when you read the next question talks about drawing a Venn diagram, and then you realize, man, I'm now doing the same thing twice and all that. So when a question asks you something for the first time, there's probably a way to do it without the Venn diagram. But again, I'm not going to force you. If you feel that drawing a Venn diagram right away would work out, you are more than welcome to actually try that out. Anyways, what are we going to do now? Well, we're going to go for the fundamental theorem of probability. Let's go for it. This is 11.2.1. The fundamental rule says probability of A or B is equal to probability of A plus probability of B minus probability of the intersection. And if you note the question is actually asking us for this probability of the intersection. Now, what we have established here is the probability of the complement, right? And it is 0.1. So if the probability of the complement is 0.1, please remember, it means then that the probability of the actual will be 1 minus 0.1, which in this case will be 0.9. So I hope you do note that that is the implication of that statement there. So it's time for substitution now. Let's put in what we have. So this is a 0.9. And what is this? 0.5. What is this one? 0.6. And we are looking for this one. So obviously you add a 0.5 excuse me, to a 0.6, you're going to get a 1.1. So there's a 1.1 minus the probability of A and B. And then this is a 0.9. Now watch what's going to happen. I love what is about to happen. There's two ways to this. You can either move what you are solving for, this to the left so that it becomes positive, which is probably maybe the best way to go about things so that everyone understands. And then you are left with a 1.1. You move the 0.9 to the right, it becomes a negative. So obviously then the 1.1 minus the 0.9 becomes the 0.2. And just like that, we have found the probability of the intersection. The next question is now drawing the Venn diagram. And if you notice, this question comes because you now have all the information. You now have all the information that you need to set up the Venn diagram. We know already there's a 0.1 there. And then we know there is a 0.2. And I want to emphasize something here. Whenever you are setting up a Venn diagram, and you will see when we do probability for 3 events, it is always important that you start off with the intersection. So that's 0.2. We know, we just calculated it. But remember, probability of A is 0.5. So we have to subtract that 0.2 from the 0.5. And that will obviously give us a 0.3. The same thing with B. We have to subtract the 0.2 from the 0.6 so that we have a 0.4. Now, you can check for yourself whether all these numbers will add up to a 1. All right? If they don't, then you know that something is terribly wrong. I'm talking about these numbers, the 0.3, the 0.2, the 0.4, and the 0.1. This is not a number, it's a B, so it's not a 13. Okay, so this is what we have done right now is what we refer to as a probability Venn diagram. So if they ask you for a probability Venn diagram, they're talking about a Venn diagram that represents probabilities instead of your usual outcomes in an event. Right. Now, 11.2.3. I want to talk about this one and warn you about notation, the way you present your argument. Remember, I said in mathematics, we are still in a language class. So there are rules to a language. There are rules of writing, you know, and that's why your teacher will penalize you if the sentence construction is incorrect, etc., etc. Mathematics, we do the same thing. If your approach to a problem is incorrect, even though it does somehow show that you have the idea and all that, but if the notation, the way you are presenting is incorrect, you will be penalized. So this question here, which says show that the events are not independent, you cannot start by assuming that they are independent. So let's remember the test for independency. The test for independency says probability of A and B must be equal to the probability of A times probability of B. Now, one of the common things that students do is, since I'm supposed to show that these two are not independent, students will then start by doing this. They will say, well, probability of A times probability of B is not equal to that. And my question is, well, where have you shown this? You have not shown this. This is actually what is supposed to be your conclusion. But then this conclusion is supposed to come after you have shown the calculation on the left-hand side and the calculation on the right-hand side separately. So I hope you don't get to make this error. So obviously we have established this up to now because they are saying use the calculation. So we know already that probability of A and B is 0.2. This is from the previous question. What we have not done and we must do now is to show that when I multiply probability of A times the probability of B, I'm actually going to get something different because they are saying we must show that they are not independent. So obviously you are multiplying the 0.5 times the 0.6. Let me just talk about notation right here. You see, at least in South Africa, when it comes to our math, when we write a comma or point something, we use the comma symbol. The dot symbol is commonly known for multiplication. So to avoid the confusion, please take note that whilst your calculator is going to use a dot for a comma, that is actually not the case in writing. When you write, you must actually use a comma, not a dot, because a dot is commonly known for multiplication. These are the little things that easily cost you a distinction in your final exam. So please take note of that. So obviously we multiply the 0.5 by the 0.6, we get a 0.3. Now guess what? I can now conclude that, well, I have done the separate calculations and my findings are that probability of A and B is clearly not equal to the probability of A multiplied by the probability of B. And therefore, the two events are not independent. A and B are not independent. Then you'll conclude that. So please, when dealing with questions like this, proving that something is not something or something is equal to something, you can never start with your conclusion. Please. Right. Moving on, we've got events A and B, and we are told these are independent events. What does that say to you? It says to you that probability of A and probability of B is equal to probability of A times, and I can use a dot there or the multiplication sign, probability of B. That's what it means. And surely we have seen already, if we are to multiply probability of A by probability of B in this case, we're going to get 0.3. Now, look at question 10.1.1. This is what we would refer to as a knowledge question. It's a level 1 question. It's a question you should be able to answer from just knowing what mutually exclusive means. So, as you can see, are the events mutually exclusive? The answer is no. They are not mutually exclusive. Motivate your answer. Now, you may want to write a sentence and say, well, since they are independent, probability of A and B is equal to 0.6 times 0.5, which is obviously not 0. And because it is not 0, surely these are not mutually exclusive. So that is that. And then represent the information on a Venn diagram. So this one, let's do it again nicely. Watch. There is a piece of information that is not given here. And that is why I'm doing this, so that you are aware that not everything is always given. So sometimes you have to actually use the principles to figure other stuff out. So we have already established that the probability of A and B is a 0.3. So let's start there. And always important to label things. So that's the sample space. Now, I know that the probability of A is a 0.6, so I must subtract the 0.3 so that I know the probability of A only, so that is obviously a 0.3. And then I must do the same thing with the B there, that will be a 0.2. Now, it is time to check the math. If I add up what I have so far, do I get a 1? And the answer is obviously no. 0.3 plus a 0.3 plus a 0.2 will only give you a 0.8. So there is a deficit of 0.2, which means we must have a 0.2 outside the union of these two events. And that is what then your Venn diagram will amount to. I can tell you now that there will be a mark for that 0.2. Cool. Now, time to calculate the probability of only A. Yesterday we talked about the importance of knowing the difference between only A and A. And I repeat again, I want to show you, if I want only A, it means I will shade the part of A that does not involve the intersection. But if I want A, then I will have to shade everything including the intersection. So in this case, it is quite clear that because we are looking at only A, we do not want the intersection. So from our Venn diagram, we can see that the probability of only A, or A only, is 0.3. Yesterday, we talked about De Morgan's laws of probability, but again, not everyone gets them. And that is the objective of question B here. Question B is checking, do you remember De Morgan's laws or laws of probability? The probability of not A or not B. And I want to remind you now how to go about that. Watch. I'm going to take you through a process of understanding what happens when you take the union of not A and not B. So let's assume this is A and this is B. Again, the same thing here. That's an A and that's a B. So I'm going to shade not A in the one Venn diagram, the one on the left. I'm going to show you what not A looks like. This is what it looks like. And I will shade also what not B looks like. Obviously, in each case, not A means whatever is outside A, and not B would mean whatever is outside B. So that's what it means. Okay, so look at that. Now, remember the word or in itself means plus. It means union. It means combine. Meaning bring these two together. So, for us to get our final Venn diagram, we must have an understanding that we are bringing these two colorings together. Nothing must be left out in the two colorings. Now, as we bring these two colorings together, it is very important to note that the only thing that is left out is the intersection. I'm actually going to do it in a very literal sense. Let me start with the blue. I'm going to bring the blue coloring to life in this diagram, which is not A. So there it is. Now I'm going to bring the green coloring. Watch. That's what it is. And I hope you note that the only thing that is left out here is the intersection. That is what is left out. It is the intersection which we have calculated to be also a 0.3. So you see, if I just wrote a 0.3, you could easily confuse that with A only. All right. So please beware of this. And I want to write down De Morgan's law in this context. This is what it says. It says, if you are working out the probability of not A or not B, this is actually equivalent to just working out the probability of the complement of the intersection. In other words, whatever is outside the intersection. So probability of A or not B is essentially probability of not what? The intersection, which is A and B. So it's okay if you cannot prove De Morgan's laws. Setting up a nice diagram like this helps out. But please, this is something that you can do for practice. You don't want to waste your time in an exam doing this. This question is worth 2 marks. So if you know your De Morgan's laws, I want you to see how you can easily actually see that the answer is a 0.3. But if you have to draw all these 3 diagrams that I have drawn to actually figure out how probability of not A or not B looks like, I promise you, by the time the invigilator says time up, you will not be done with this. Okay, the standard rule in an exam, time management is important, is that please try and work with what? With the mark allocation. So what I mean is that if they say 2 marks per question, do not spend more than 2 minutes on that question. If they say 3 marks, do not spend more than 3 minutes on that particular question. And I know some of us, we want to write neatly and all that, but writing neatly might cost you, especially in this context of a Venn diagram. Okay, I'm not saying you must write badly, you see, but trying to draw a nice Venn diagram and all that will not earn you marks, might cost you time. So you need to maximize and do what really matters. And what matters is showing us that you actually understand and know your work. All right. Cool. Let us do another one. Okay, we still have some other nice noble questions to do. Let's maybe take 1 more or 2 more. Maybe the others, I will give those to you as a homework to just try and see if you have really understood what we did here today. Okay, the sample space S is the set of natural numbers less than 10. Now, what are natural numbers? Natural numbers are counting numbers, usually used for counting living things, isn't it? This is taking you now back to grade 8, where you learned about number systems. But even in grade 10, number systems are still reviewed. So the sample space here, the smallest natural number will be a 1. So beware of that. Again, this is a nice one because then we are setting up everything from scratch. So natural numbers less than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We cannot include 10 because they said less than 10, smaller than 10. So 10 is not part of this. Now, look at how they define events A and B. Event A is the set of even numbers. So from the sample space, we can have event A, and that event A will comprise of the following: 2, 4, 6, and 8. Because those are the only even numbers from the sample space. And then we've got event B, which is the set of prime numbers. And I mentioned this yesterday that please, 1 is not a prime number. So the smallest prime number in this set is 2. After that, we're going to take 3. We're going to go for 5. We're going to go for 7. We stop there because 9 is not a prime number either. Okay, very, very important. So 2, 3, 5, 7 are the prime numbers here. Remember, a prime number is a number that takes only 2 distinct factors, namely the number 1 as a factor and the number itself. So if you look at 2, 3, 5, 7, you will find that, okay? So time to set up a Venn diagram. Let's do that. That is question 8.1.1. Okay. Looking at set A and B, I can see already that 2 appears in both. So these events are not mutually exclusive. They are inclusive. So there is something in common, and that is the element 2. Then I will label clearly that on the left I've got event A, on the right I've got event B, and that the box, the entire box, is the sample space. So for event A, I have already indicated the 2. There's no need for repetition. So what remains is the 4, 6, and the 8. For event B, 2 is already there. Then I'll have a 3, 5, and the 7. Now it is time to check. Have I actually accounted for all events that were in the sample space? The answer is clearly no. The 1 is not accounted for. Yes, 2 is accounted for, 3 is accounted for, 4 is accounted for, the 5 is accounted for, the 6 and the 7 as well as the 8, but the 9 is not accounted for. So I must have 9 natural numbers in this Venn diagram. You do a quick check, you realize indeed there are 9 natural numbers. So now you know you've got a full representation of all the numbers. So this is the complete Venn diagram. Done. 4 marks for free. Question: are the events A and B exhaustive? Again, the importance of knowing words and their meaning. We talked about exhaustive events. We said exhaustive events, when you combine the elements thereof, they will make the entire what? Sample space. And that is not the case here. Surely there's 1 and 9 outside. So these events are not exhaustive. Why? Because they do not include the 1 and the 9, okay? Or not elements of the sample space are represented in their union. That's another nice way to put it. Now, 8.1.3 is asking for the number of outcomes or elements in the complement of the union. You see why it is important to understand notation. Okay, this here is basically saying, remember, I had always said to you, it is always a probability of event A. Remember, I said refers to the number of elements in A over the number of elements in the sample space. So you've got to see, again, I promise you, it is not that you don't know the number of elements outside the union. You do know. The problem here is, what does this thing mean? What does this N of A union B prime actually mean? And I hope you've seen the point here that I always drive, that please know the symbols, the notation that is being used in mathematics, because that is what is going to really unlock your ability to answer or respond correctly to the question that is being posed. So surely A union B refers to or is the same as what? A or B. But then what does A union B prime mean? It simply means not A or B. And that means whatever is outside A or B. Now, what does N of A union B mean? It implies the number of elements that are outside this. And I hope you can all see there is only 2 elements, namely 1 and 9. Finally, what is the probability of drawing an even number and a prime number? And I hope you notice how they have bolded the word "and" in this case. They are trying to say to you, we want the probability of the intersection. Remember, drawing an even number in itself is the event A. And drawing a prime number in itself is the event B. So they are essentially checking, do you understand that we are asking for the probability of the intersection of A and B? Or if you like, you may say probability of A and B. That's what they're saying. Do you notice that? Now, how many elements are in the intersection? There's only 1 element. It is the number 2. But overall, how many elements are there? We know the sample space has 9 elements. So that probability will be a 1/9. All right. So, guys, this is the long and the short of it at a very primitive, basic level. If you are in grade 10, you should never struggle with probability, having understood what we covered today. And if you are in matric, this is a warning to say, do not forget your grade 10. You are in grade 11. This is just an opportunity for you to look back on what you should know before you get to understand what you are currently doing. Go and try this question. See if you can do it. You are told that event S and T are actually independent. I hope you remember and know what that means. And secondly, you are given the probability of S and T, which is 1/6. You are also given the probability of the complement of S, that is not S. It is 3/4. Your job is to calculate the probability of T. And if you know the probability of T, then calculate the probability of S or T. I'm getting excited and tempted to do this, so I will leave it there. You're more than welcome to just take a screenshot and you go and try it. Just test whether you have actually understood the concept. Another one to try out is this one. Again, we are told here a group of learners were asked whether they play rugby or cricket as a school sport. 45% of the learners indicated that they play rugby. Remember, I said to you, probability can be presented in terms of percentages or decimals. Okay, so here you've got to know what 45% is in a decimal. Okay, so 45% of the learners, they play rugby. 15 said they play cricket. 40% said they play neither, and none of them play both. None of them play both. That statement is not there for fun. It is telling you something. And I hope you caught what it is telling you. Again, I challenge you. Try and see if you can set up a Venn diagram for this. And that Venn diagram must make sense. When you are done with the Venn diagram, next question. Would you regard playing rugby and cricket as independent events? By now you know the test for independency. And again, let me not spoil the fun for you. You will know what to do. All right. When you are done with that, then you are welcome to actually, maybe in the next session, we will VAR that and review it and see, so that you get to see whether you have done the correct job or not. Now, this is for grade 11s. Once you are done with grade 10 stuff and you have thoroughly perfected them, we come to grade 11, where now we do Venn diagrams of 3 events. And again, this is going to be another fun time, but this will be in another session. For now, go try this question and this one question. Only 2 sums